Okay, after we finish, let's continue with the second video. After we finish with this water content, after being corrected by the density, specific gravity, and solid content, so we have a water content. If we have impurities, how to do that? So there are three methods. The first method is we calculate that the fraction of each of the impurities, CO2 and H2S, and then we by using a chart, we will calculate, we will find out the water contents of the H2 and CO2, and of the hydrocarbon has already been calculated up there. And you should know that this is just for you to understand that the basic thing about how to get this water content. So first is water content H2S between figure 2010, and CO2 between 2011. And let's go to this graph 2010. So this is the 2010. So a little bit okay, minimize a little bit. So this is how we come up with the water content. So the temperature is 150, and we find that our pressure is 1000 psi. And after this psi, we go to the lab and we find out the water content of H2S, which is around 100, 200, and 300 pound mass per million standard cubic feet. Okay, and then also the same thing for the CO2 is 150 degree, and find the pressure 1000 psi. Going to the left, this is around 200 something, 220 or something of a pound mass of this one. And then so go back to this number one. So we have 240, and then we just calculate. So basically mole fraction of hydrocarbon, which is 1 minus 0.35, 0.65 multiplied by 198, and then 0.15 multiplied by 300 for H2S, and 0.2 multiplied by 240 for CO2. So we come up with 221.6. Okay, and then the second method is kind of different. First, we use the mole fraction of H2S pseudo, which is a combination of mole fraction of H2S and only 75% of mole fraction of CO2. So in this case, the pseudo is H2S is 0.15 and plus 75% of CO2, which is 0.15 also, and then the pseudo become 0.3 mole fraction. And then we see the what is the barrel of water in the million cubic feet from figure 2012. Okay, let's go to figure 2012. This is figure 2012. On the left hand side, we have a small pressure, which is 300, 1000, and 2000, and on the right we have 3000 and then 6000. So first, remember that we have a 3% of 30% of H2S. Remember that? So this one we use number 4. 30% of H2S and 70% is CS4. So we have a temperature here 150, and then the pressure is around is 1000. This is 1000, and go to the left, and we come up with around 0.7 something. So 7 8 7 8 9 10. Okay, 7 something, 74 or something. Probably I don't remember. And then we find. So let's go up here. Number 2. So 73. So we get the 73, and the density of water is a constant. Is 350 pound mass per barrel. That's water, is pure water. So if this is a constant, you have to remember this number, okay? 350 pound mass per barrel. So we have a water content of everything with H2S in it. So, and it's not just H2S, but the gas, all of the gas. So become water density 350 multiply by barrel per million cubic feet of 0.73. So we end up in 256 pound mass per cubic feet. That's number 2. But I have a note in here. I forgot to mention to you again. Another note, and this curve actually is for a small, low pressure and low temperature, and we have another one. So remember, this is 24, and we have also 25, figure 25, which is the water. The temperature is a little bit higher, which is 400 degree Fahrenheit, as compared to previous one only 300 degree Fahrenheit. So there are two types. This two is made by after Maketa and Wehe. So this is a popular one. So if you hear the Maketa and Wehe, this is water content. And this water content can be used also for the if you have a production of production of a well test, for example, a gas well test, and then a well test, and you end up with having a high water in it. It doesn't mean that there is water flowing in the reservoir. Actually, it's just still one phase in the reservoir, but it contains water inside the gas. So it's in the form of the gas. The water itself in the form of a gas. So in this case, the production water on the surface, you have to adding up to the gas. So usually what I do if I have a well test, usually I just see what is the amount of the water. If the amount of the water from the correlation is larger than the production water, means that everything is coming from the gas. But if the amount of water is smaller than the production water, means there are two phases in the reservoir, which is two-phase flow, which is water and gas. And that's it. And then for the this figure 2010 and 2012 and 2013, you see here that is kind of different between 300 and 1000. So if it's 300 or 1000, using this what you call it, x-axis, and this one y-axis. But if you have a high 2000 psi, you see this axis and this axis. You see here, for the small pressure is 1, and for higher pressure is 10. So it's different. So this 1.1, this one is 1, this 1.01, this 1.1. And on the other high pressure, it's the same thing. You see here, so it's using the left and up, and in here using the right and bottom. This is a 10, this is 1, this is 0.1. So it will be a difference between one another. So you have to be aware that where should I put this, right or left. Okay, stop from here. We will continue later with the video number 3.